Good afternoon, ladies and gentlemen. It's my pleasure to introduce Ken Klingenstein, who has made great personal sacrifice, he tells me, to be here for 4 o'clock. So thank you, Ken. I think we all know Ken, Director of Internet 2. He comes to virtually every Torino conference and gives talks, and he gave one of the keynotes last year for those people who were present. So over to you, Ken. Thank you.
Thank you. So the personal sacrifice, just to get that out of the way, is that the only time you can walk along the walls of the old city is Tuesdays at this time slot. So I wanted to go to that, but I was told I needed to do my talk. I'm not allowed to talk about the stuff that's working. I'm only allowed to talk about the stuff that doesn't work right now. So I want to talk about the stuff that's coming down the road. So there won't be, I don't think, any mention of shibboleth in here or that kind of stuff. No mention of H350 or any of the other things that have actually happened. This is the stuff that is still in the works, the newest generation of effort. Just want to give you a little bit of background on this. I want to make sure that we all agree on the model. I think we do. I think it's a very good model that we have, but I know there are members of the larger R&E community who have yet to embrace this model, and I want to spend a tad about that. Talk about, oops, it looks like I'm going to mention something about shibboleth, Signet, virtual organizations, and diagnostics. And then close with something about what you might expect to see happen over the next year. As always, I want to give credit to the people who really make this happen. Some of you have heard in the past the distinction that I'm called marketing, and these are the guys in product development. So I need to honor product development because they're very good. And marketing sometimes says things that aren't even true, but that's what the tradition of marketing is all about. Very good people, some of them you know real well. Notice the international participation. We are tremendously indebted to Diego and Brian and Tan for their participation. And we create working groups along the way. In particular, in the U.S., Internet 2 has been working in the middleware space for the last 5 years. We get lots of support from university members. All of the technical staff that have been working in this middleware space live on campuses and work there. We have a grant from the NSF, the National Science Foundation, to do a little bit of this work. That grant has two major themes. One is scientific and computing a la grids, and the other is the campus enterprise middleware, the piece that we do. I'd love to say that the grid community has thoroughly embraced these ideas. They have not. They're getting much, much closer, however. Very close. There's meetings later this month that may help anchor this. I believe the grid community and virtual organizations are suffering from their own success, as many of us do, and need a more scalable option, and they believe that we can help provide a more scalable option. But stay tuned. We issue periodic releases of software, services, architectures. It is the way that these documents get out into some of the public space, and R5 is the most current one. Torino has been an anchor for lots of international efforts, and certainly in the attention it's now playing to the middleware space. We are deeply appreciative of the work from the Swiss. They do SHIB better than we do SHIB. Spain, again, Diego and Red Iris. Tan showed me something a few minutes ago that was just amazing. So I feel very lucky to be part of a very active international community at this point that is seemingly moving forward in some degree of coordination. Want to highlight in particular some work that JISC has undertaken in the last month, some very important stuff to our community in terms of virtual organizations, digital rights management. I will give you the URL of their webpage announcing their projects. Very, very important. I would also point out that the Australians are starting to invest heavily in this space, but the rest of the Pacific Rim has not yet come to the table. That's unfortunate. Many of the virtual organizations that we want to support are global in nature, to the degree that some part of the globe does not have infrastructure to support those virtual organizations. We will all be the worse. So what is this model? The model is around enterprises and federations. Given our strong need to collaborate as a community, we need to create inter-realm tools. So we did that by beginning to develop common infrastructure on the campuses where middleware tends to happen, so that the campuses were free to do as they want, because we're not going to tell campuses what to do, but that the outward-facing visage of the work would be consistent. So those outward-facing service points could be tied together into a supportive interinstitutional fabric. And now we are federating among those enterprises, using those outward-facing campus infrastructures with inter-realm attribute transports like SHIB, with trust services like federations, with object classes like H350 and EduPerson. So we're beginning to actually use those outward-facing aspects of the middleware infrastructure to provide services. We're doing it for more than web services. We're trying to do it for network authentication, much as the JRA 5 project is about. Instant messaging, video, and then we want to create tools and templates that support the management and collaboration of virtual organizations, and that's the piece of work that JISC in particular is providing vision and leadership for. I should mention, well, let me move on. I'll get back to that. Some of the work that we've done as axioms is we work the core areas. We focus on support for collaboration. We use federated administration as the lever. Consistent directory infrastructures. Provide security while not degrading privacy. Foster the inter-realm trust fabrics. Support heterogeneity and open standards. Influence the marketplace and develop where necessary. And I think the R&E community is influencing the marketplace in a way that hasn't happened in the last 15 years. We did that originally with TCP/IP. I think we are again exerting global vision and leadership in this next layer of connectivity. So this is how we see the world in middleware land, that we work the core middleware space. There is network layer middleware, that things like network authentication, like quality of service, like secure multicast. If we are ever going to A, do multicast, and B, do secure multicast, how are we going to do that? We're going to need middleware to make that happen. Above this, then, there are distributed computational environments such as the grids. There are directly enabled applications such as desktop video, instant messaging. There's virtual organization support. And then there's other areas as well. And we need to make this work for the campus infrastructure. We need to make this work at the desktop, which means that we have to go to Redmond, Washington. And then we need to make it work for the discipline, because many of the high-end users that we work with, yes, they belong to a campus. Yes, they have a desktop. But first and foremost, they're a particle physicist. And that is their biggest allegiance. And they want to see the world as a particle physicist. This less flashy graphic talks about how we see federated administration. CM stands for the core middleware. Most campuses deploy core middleware because it makes their own local applications work better. The biggest win is that send mail works better if you have a directory. So you build these core middleware pieces to support applications, but we suggest to campuses that you also put in the external facing origin and target components of middleware, and then we can work with each other. We can work with targets that are things like Elsevier, perhaps like CERN for the question that I asked earlier, and we can also work with virtual organizations. One more preamble, and then we'll get into current events. We talk about the unified field theory of trust. Big phrase. There are several different trust hierarchies several different trust mechanisms out there, and our goal is to make them work together. We tried one PKI and discovered it was hard to do and it didn't fit all things. But there is still a role for PKI, and we still work very hard on it, and I think we're getting very close to having it service a particular set of needs for which PKI and only PKI can work. But there are other kinds of trust fabrics out there. There is the federated one. It is enterprise-based. It leverages one's primary security domain, and it deals a lot with roles. Your role as a PI and your ability to assign responsibilities in that virtual organization. Your role as, in the U.S., your role as parking coordinator makes you a very important person on campus. So the enterprise does the authentication and the attributes, and the federations exchange assertions, and those assertions can have identity or just have attributes. And then new to the game, though it's been out there in the past, is peer-to-peer trust fabrics. And we tend to think about them in our real lives. It's how we generally get by. They're small focus, they're ad hoc, and now there's new technologies that are bringing peer-to-peer trust into our world. PGP was the first example. There is in Longhorn the new operating system from Microsoft in 2006, or if we're lucky, 2007, or if we're really lucky, even later than that. It will have a peer-to-peer trust fabric that is very good. There is an old saying about Microsoft, it's not just that they're evil, it's that they're good and evil. They are good. This is a very nice trust fabric. It uses PKI, self-signed certificates, for developing credentials to pass among friends. Those credentials will be able to open up ports on your desktop firewall to allow video conferencing and file sharing. And you sitting there as a user will have now lots of different trust fabrics, lots of different reasons why you trust people, perhaps a lot of different certificate stores if we're really sloppy about this, and the question of how we educate users about these trust fabrics and which ones are permissible for which kinds of operations. It is a complexity that lies before us. On the other hand, if we could get my grandmother to do backslashes in HTTP, we may be able to get people to do to learn over time how to manage trust in the electronic world, much as they do in the real world. Lastly, virtual organizations will ultimately leverage one of these trust fabrics. So let me talk about the deliverables. Shibboleth, I think you've heard too much about. Signet is a meta-authority system that leverages enterprise roles to drive authorization. I'll talk a lot about Signet. We are very excited about the potential inside Signet. No doubt we can biff it. No doubt we can blow it, but we're trying to make this really a success. Virtual organizations, I want to talk a little bit about how we see the world and what the work that JISC might do in this space. And diagnostics is a truly hopeless activity that no one else is thinking about, so we need to, because we worry about infrastructure. And so we need to couple existent and yet to be defined exception handling across a multi-layered application, middleware, security, network, distributed environment. Courtesy of Switch, here's the SHIB architecture. This is only the third time you've seen it today. Here's some of the milestones along the way. It's been a remarkable journey. It continues. I would like to point out that the U.S. is no longer the biggest investor in Shibboleth, which is good. And we're really pleased with what's happening in that space. I would also point out that Shibboleth does not go on forever in development. It has a finite set of services that we need to develop, and then we'll be done with that part of the puzzle. There are no longer conferences about TCP/IP just by itself. It's no longer exciting. We hope to be as boring as TCP/IP shortly, and leave other spaces out there for invention. The SHIB status, it's 1 point, I won't go through all this. I would point out, in case you're not aware, that version 1.3 is likely to include portal support in a much more elegant fashion than it does today. In fact, today there is no architecture for portals. Portals happen in odd ways. Sometimes they take credentials, sometimes they pass credentials, sometimes they sneak a peek at the credentials. There's lots of very difficult issues in doing this properly. We are starting to work with uPortal and anybody else who's doing a portal to come up with a good approach. There's also work going on identity linking. There's lots of times when you want strong linkages between identity and not privacy, non-web services, etc. There's also work going on the graphical user interfaces. The attribute release policy for a sysadmin to set attribute release so that everybody going to Elsevier will have the attribute entitled to this particular subscription with that identity passed along. Those things, those GUIs are coming along very well. We're working closely with Liberty, and we're very, very, very hopeful that we will be building WS Federation interoperability into SHIB. That's something that Microsoft has asked us to do, which is unusual and may not persist. Lots of people using it. Needs federations to scale, as was pointed out earlier in your presentation. We need to start to work those issues together. So that's the update on SHIB. I just one other aside. We're learning to create a more widely managed environment for the progress of SHIB. I sit on the Grid Forum Steering Committee, and that has given me a lot of opportunity to learn what not to do in generalizing software. So we will try not to make those mistakes, though there are lots of others we can make. So the Global Shibboleth Federation is not, a forum is not in the cards, thank God, but some kind of coordination mechanism definitely is. We like the lightweight open LDAPs of life, the Mozillas of life. Those seem to be more the flavor that we're comfortable with than other things. Signet. Signet is the Stanford Authority System. It's been in production now for several years at Stanford. It is, in some sense, a meta-authority system. One defines roles for people, and then those roles translate to a specific set of functions that you can do, and those functions in turn translate to specific tasks. And there are some examples up there from Stanford today. All of that is business. On the other hand, what we're really caring about is applications. And the problem we're trying to address is, how many applications do you need to be configured with permissions into? That number is growing rapidly. It may not be manageable today for you. For me, on the university campus, there's probably 40 systems that I need permissions for. Each one of those is entered separately. When I leave, how many of those are cleaned out? How long does it take to do that? Does it take longer to create my permissions than I stay at the university? That would be awkward. So there's lots of issues here, and Stanford has approached those now with the authority system that sits in some sense in front of these applications, and you only configure a user into the authority system. And then out the back end of the authority system, permissions are pushed into the applications that need them. So it's not like Spock P or other situations where you wrestle the business logic from the application out into some third-party policy mechanism and then do the policy decisions there. If you think about your student information system on your campus, are you about to wrestle the logic from that out of that program? Are you going to talk to PeopleSoft or SAP and tell them that they should externalize all of their decision-making processes? And I don't think that's about to happen. So we think it's better to make the configuration of users within PeopleSoft not have to happen with a PeopleSoft panel, but happen in only one place inside the institution, and then it gets pushed into PeopleSoft. It gets pushed into calendaring. It gets pushed into your course management system. It gets pushed into your parking management system. So the idea for Signet is to, in some sense, just as we learned that meta-directories were in fact more important than directories, meta-authority may be as important or more important than the authorization decision itself. That's the goal for Signet. Signet has been in production at Stanford for several years in its non-generalized fashion, and it offers a number of unique capabilities that we have not seen elsewhere. First of all, it helps configurations. But a lot of times, there are issues that you want to get answered with an ad hoc query that you can't get answered inside a system. So, for example, let's take a PeopleSoft financial system, and you wonder, or a human resource system, and you say, who can sign this form? The person who, in my department, can sign this form is on vacation. I need someone else in the university to sign this form. Who can do that? You can't get the answer from PeopleSoft. You can't look outside your unit. That's the security inside PeopleSoft says, oh no, Oliver, you can't go outside this. You work for the IT unit. You can't look to see if there's somebody else 3 doors down who can sign this form for you. Inside Signet, you can do that. It is used heavily for that purpose at Stanford. It is a real win. The auditors love Signet because there is now one place to go to watch for changes in permissions. Signet has the capability to manage people who may not be inside the application system otherwise. So on my campus, perhaps on your campus, we give keys on occasion to people who are not really members of the campus. It's handy. So if you want to know who has access to a certain door, you can only tell which members of the campus community has access to the door, but you can't tell who else may have access. With Signet, you have the ability to create those kinds of queries. So the challenge here is really going to be on the right side of life, to create the kinds of plugins where Signet can now say, you're going into WebCT. We'll create your capabilities inside WebCT to fit your profile and your role in life. So a lot of work sits in those plugin modules. On the other hand, if we do these plugins right, we can share them, and that work can be spread out over the entire R&E community. So what we're going to be delivering in Signet is a recipe that talks a little bit about how you take a role-based organization and develop appropriate groups, policies, attributes, registries, all of the internals to drive an authority system. I don't know how many of you have role-based organizations. Thank you. Yes, it's in higher ed, it's much work will go into getting to the role-based organization. If the payoff is there, it will happen. To give you, I'm watching Andrew nod his head, and to give you a taste of how important this issue of limiting the roles is, when Stanford first did this, the pull-down menu for what role you could assign to somebody was 900 entries long in a 1-by-1 box. It paid. Now, you can capture the old wine in new bottles, but it would be great if we could do new wine here. So there is work here for the campuses to organize that stuff. Your choice. Templates and tools for registries and group management. A web interface and program APIs to provide distributed management to the departments. I'll show you some of these. And the delivery of the authority information through the infrastructure as directory data and authority events to all these applications who want to consume the authorization change. This is a version of the Stanford work today. This is the home page for the Authority Manager. What will be distributed will be infinitely customizable, so you can make the screen look like whatever you want, whatever your campus symbol happens to be. The roles can be whatever roles you want. The permissions can be whatever permissions you want. All of that is customizable and driven by tables, and we're providing the framework. But if you look at the functions, you can grant authority, you can view authority, you can find a person and assign authority, and you can look at the authorities that you have. And then down here, you may not be able to see it, there are what we call designated drivers. The ability for you to say, oh, I'm going out of town for a week, and so for the next week, this person can do these functions, and that responsibility ends at the end of a week automatically. But if somebody says, gee, who's doing Jennifer's job today, and she's away, this will be able to answer it. To grant authority, I can grant authority to a particular person, pull-down menu, what kind of authority I want to give, approval authority, what is the scope that they can work over? Well, they only work for this particular unit, so here's the scope. Approvals, all approvals, no, just requisitions. Are there limits to what kinds of requisitions they can approve? Yes. When does this permission begin? So you can have prerequisites. The prerequisites can be things like training. Frequently, that's a prerequisite. Other prerequisites can be established. It is yours to choose. It is a table of prerequisites. Notice that there's an expiration date, and you can override the expiration date. So and then lastly, and perhaps very importantly, whether or not you can delegate this privilege to someone else. When you start to look at authority in this high-level context, it turns out there's a fairly standard set of functions, and these are most of them, that you want to do in managing authority. So the complexity comes in its application, but not in its design, and this is the way to do that. So that's Signet. We have an email list set up as Signet begins. We have a workshop coming up later in June that I think some of you will be at in the U.S. to begin to share knowledge about this. We expect software to be emerging over the next year in pieces to create all of Signet. The recipes will begin with a recipe from one or two institutions, but we'd like places that are interested in deploy this to tell us what were their issues, as much about the policy space as about the technology space, because authorization is really there. Tell us how you reduced the number of roles from 900 to 2. Yeah, tell us that one. Okay. So virtual organizations are geographically distributed enterprise. You know what these are. You have some in your backyard. You have some grid experiments. You have some digital rights sharing going on. You have a set of museum curators from multiple museums who are trying to work together. And we want to help support them. Some things seem to be consistent across all virtual organizations: the need to manage and delegate authorizations, naming, resource discovery, and a list of collaboration tools that people like Jill are working on for their support, and the need to factor in and leverage local domain requirements and capabilities. It is not merely that I could offer to David the capability in my virtual organization to use my desktop because he's not a U.S. citizen, and my campus says that there are restrictions imposed that way. So in many VOs, you need to factor in, I was talking to Karsten about all of the administrative structure that the states impose inside Germany, and I'm sure they have lots of rules that would govern who can do what, no matter what the virtual organization might say. Now, the VO won't claim that, but they have to acknowledge it eventually. So some things are specific to the VOs, et cetera. We need a model. We need to move forward on this. JISC has the lead. The solicitation is off the streets. It's been awarded. If you go to that website, you can find out what the awards were that were made. We're working closely with them in this space. This is a very important task. We need to support those virtual organizations. Those people get Nobel Prizes in physics, and we don't. And so where we want to be is being able to have the VO be able to use the federation and the enterprise and the user directly to make things work. So we envision, and one of the projects that the UK is funding, is adapting Signet to work for a VO. And imagine the pleasure of a scientist on a campus at the University of Bremen who is managing his students who are in the course management system and then using the same interface but with a different logo in the corner, manages who can use certain devices in his grid experiment. And that the same concepts of delegation, prerequisites, etc., can be applied in both spaces. Conservation of interface for scientists is very useful because they're important people and we can't waste their time. Okay, last topic, middleware diagnostics problem statement. Again, way too many applications. Each application creates its own framework for providing diagnostic tools. In fact, most of them don't bother. I was asking about the diagnostics for A-Select, and I understand that it's being worked on any day now, and we're in the same situation with Shibboleth, and when everybody's in the same situation, maybe Pappy has better diagnostics, but I think we got to get this stuff to work well, folks. It also needs to integrate with network performance diagnostics and security diagnostics. The poster child for this, I can show you an instance with Shibboleth where 4 different problems create the same error message. The error message is totally worthless, by the way. It says, Shire not found. No user is going to understand that. But it can be caused by a badly performing network. It can be caused by a firewall that blocks the incoming messages from SHIB back. It can be caused by a whole host of things, which could include a poorly configured SHIB installation. But so many different things can cause the same error message. We've got to get good about this. As this gets widely deployed, help desks are going to be baffled by these calls from users saying, Shire not found? On the other hand,
It's a Hobbit message.
A Hobbit message, yes. On the other hand, again, if you think about how we've programmed people to understand what 404 means, we can succeed. We just want to be good at it. So our goal is to create an event collection and dissemination infrastructure that uses existing system, network, and application data. Create a standardized event record, and a number of us have been talking about this in the last day, and a tool and a platform for collecting this. So lots of different applications create error logs. Those error logs can be normalized and tagged into a standard common event record, and then we can begin to work with those common event records to do diagnostics. One trick in all of this stuff is that much of this software is designed to protect privacy. Diagnostics and log files totally erode privacy. So one needs to manage the diagnostic process with a sensitivity to privacy as well as answers. I won't go through all the rest of the stuff here, but you can see we're moving ahead with an event record, etc. So to close, what might you see in the next year? I think a marketplace is coming up now in identity management services. Certainly if you read the trade magazines and you look at the conferences, there's a lot of buzz about this stuff. And there will be work, home, and personal forms of identity management. Federations and international peering of trust will happen. We hope there's more integration between grids and enterprises. I would expect to see virtual organization services that are supported by the campuses, by the communities, and in many cases by an outsourced service center. In the UK, there is a grid support center. Is that the right place to run some of the infrastructure for VO support? Perhaps. We hope to see adaptation of Signet type privilege management. The trade magazines think this is the way to go, so we're excited. That may create new business models. Higher ed has a way of doing this. Sometimes it's good and sometimes it's not. And I can just tell you we will be in diagnostic hell. Things will get much worse before they get better. Thank you.
Time for one or two quick questions. Yeah.
I would like to understand how hard it is to take the authorization out of the application of something like PeopleSoft. I mean, I completely agree with you that it is very desirable to have this box sitting in between doing all this thing. That is exactly what we have successfully been doing with authentication. It seems, however, that it's very hard to take the authorization out. But you have managed that. How much does it take?
No, we're really not taking authorization out. All of the business logic sits inside PeopleSoft. What we have done is to say that if your role on campus changes from a student to a teaching assistant, that information will be populated inside PeopleSoft automatically without having to go into PeopleSoft and make those changes.
That does mean that all these applications, PeopleSoft, the student information system, all the other systems still will have their own business logic?
Yes.
Okay.
Yes, we can't take that out. I wouldn't want to look at the business logic inside PeopleSoft.
Okay, thanks then, Ken. Our next speaker, do you want to move down, Per, and then get your presentation ready? Per Thorbel from UniC, which is the Danish Education and Research Computing Centre, and Per's the Deputy Director there. He's going to be talking about single sign-on for thousands of students in the Danish Computing Centre. So, over to you. If you... Okay.
Okay. Hello. I would like to talk a bit about single sign-on in the Danish educational sector. And I will tell you a little about the problems we encountered due to many applications that we had, and some of the background for our need to look at single sign-on. It will be very much from a practical approach. I think most of you will know the tools that we have used, but I will try to tell you a bit about the considerations of how we chose those tools and what kind of problems we ran into and how we see the future for our single sign-on project. The background of this, UniC is the Danish Computing Centre for Research and Education. We are a nationwide centre, but it must be said that we are quite a small country, 5 million people, a bit above. But still we have many local governments, regions that wants to influence. And we want to give our services and products to all of the nation. And we have a large spectrum of products and services. First of all, we have the basic network. We have something called the SectorNet for education and the research network for the universities. We have different kinds of security solutions, infrastructures and services, content services, intranet solutions, and student information systems and ERP systems of different kinds. So you can say that we cover the whole spectrum for education and universities. When we look at the institutions, we start with the primary education, secondary education, colleges, vocational trainings, and we also have all the Danish universities as our customers. So you can say that the total of the Danish research and education sector is actually our customers. The single sign-on project was only meant, in the beginning at least, for the educational sector. That is K-12 plus the colleges and the vocational training. For those, we have a lot of products. These have been developed over the last 10, 12 years, and they are very, very different. I will not go into detail with every one of them, but just mention that something as the toolbox, which is something that is for the system administrators on the network, which makes it very easy for them to see what is actually going on the network. They can order logs, they can order different filtering on their firewall, etc. We have something like Skoda, which is down there, number 4, which is the school database system, and which is a collection of commercial suppliers, commercial content providers, who have we have collected and then sell to the schools. Skolecom, this one down here, is a big conferencing system, conferencing and email system, where we have most of the Danish schools as users. We have Blackboard, which some of you may know, a learning management and course management system, which we have are supplying as an ASP service to some vocational schools. And we have all these different applications, some of them built on Lotus Notes, some of them we have built ourselves. And they are in fact running in practical, they are running on each of them are running on their own server. Some on one server, some on 2 servers. But it has been very difficult to coordinate the user administration on these systems. As we grow the number of applications, we can see that the number of systems, of course, are growing, the number of system administrators, and the number of different user ID password combinations that the users have to remember. This are causing problems for UNICE as the service provider. This is causing problems for the user, and this is in fact also causing problems for the publishers, the people who want to sell their services to the educational sector, because they have a very hard time coming in with something that where you need authentication and authorization. So all of this led us to believe that we had to have some kind of single sign-on service for the educational sector. We formulated a vision that we wanted to provide a unified login for all IT services in the Danish educational sector. This was, and this still is, our goal. It is, however, not practically possible with the technologies that are available today. Some commercial vendors might say that it is possible, and we spoke to some of them, but it seems that their products are very expensive, very, very expensive, and also very narrow in some way. And I mean, there are a lot of them out there, but we couldn't see that any of those could actually be used. So we had to take a more pragmatic approach in order to see what could be done. Our current goal, then, is to build a national authentication and authorization framework and provide a unified login for web-based services. This, as I will explain, this is going quite well, and we have come a long way. But the vision is still to provide a unified login for all IT services, and this should also be possible. We had, in fact, a very good starting point, which I think is one of the reasons that we could actually do this single sign-on project in a very short span of time. We had namely this Skolecom system, which was one of the products we had, where we had user ID passwords for more than 500,000 users. If we look at the total population within the Danish educational sector, it is approximately 600,000 users. So we had most of them. We only needed the last 100,000, and we also got those last 100,000 in. And then we could take out the user information from the Skolecom system and use that to populate a centralized database based on an Oracle technology, where we now have all the users with their names and their service codes, so we can see what they are allowed to access from all these different services. We have a delegated administration. We cannot sit and administrate access rights and user information for all the users. So the administration is delegated out to all the schools. Each school, whether it be a primary school, secondary school, a college or whatever, is responsible for the information that is in the system. This has been accepted by the schools because they can see the kind of advantages that it brings them. And we are also working on automatic integration with the administrative systems in order to get that administration more automatic. But at the moment, most information is entered by hand by the schools about the students. This central database forms the immediate basis for the authentication and authorization control. Our first step was single login. It was not possible for us to realize the single sign-on, but we could make a single login quite easily. We used the central database, which we called Hugo, to populate an LDAP database with passwords and access rights. This could then provide the authentication and authorization service, which we call single login. Every application could use this LDAP database, and we told the system administrators on the different products how to do that. This is good in many ways, and most systems are coming over to the single login, but there are some problems with it. Of course, the users have to log into each service, so we have now one user ID password, but they have to use it several times. And some of the users may have 10 or 15 applications which they're using, so they have to log in several times during a day or even during a couple of hours, which seems a bother. This can also make it more difficult to protect. We have more weak spots, so to speak, where the user ID password is vulnerable. And in some cases, it has been necessary to send the unencrypted password between the systems. Of course, this is something that we try to avoid to do, but some applications are so old-fashioned and difficult to change, so we have to send the passwords unencrypted. This is not good, of course. So we tried to look at what kind of concepts we could use for single sign-on. And in principle, we considered these three different authentication schemes. The first was the proxy. The idea with the proxy is that we build a proxy ourselves, which is this, and that will then lead to all the different applications. The authentication will take part here, and it will then lead the user out to the different applications. Then we considered the PKI solution, where you have certificate-based authentication, and the applications will know whether that certificate can be authorized to use that application. And as the last one, we consider this cookie-based, where the user goes directly to the application, and there is some kind of login server which takes care of the cookies. I'll try to explain a bit more about each of them and what we saw as the advantages and the disadvantages. Well, if we look at the proxy solution, there's an independence of applications. You can have this proxy as a standalone, and you don't need to bother very much about the applications that are behind. All protocols can, in principle, be supported, and we did, in fact, develop such a solution. We developed and maintained it in-house, and it was seen at some stage as the solution to single sign-on. But there was a problem, namely that as the number of applications grew, it was very hard to make it scale. Of course, the initial code was rewritten and we tried to optimize it. But when you look at 600,000 users with a more and more active use, you can see that the scaling problem just was not possible to solve. And it was non-standard. We had to maintain knowledge about the proxy solution ourselves. PKI. Most of you, I think, have at some stage considered or have actually deployed PKI. PKI has a lot of beauty in it when you look at it from a theoretical point of view. But when it comes to the practical issues, then PKI is a bit harder. It's hard to use for the end users. You have to have control of how the end users are actually behaving. In schools, we often have many students using the same type of equipment, so you have to go to smart cards, and then there's major investments at the school. Certificate management is very cumbersome. Cross-certification, certificate revocation. There are a lot of practical issues in PKI, which made us think that that might not be the right solution, although it has its advantages known to most of you. Then there was the cookie solution. Well, cookies have always, when you talk to security people, it has always been like cookies is not so good to use, cookies is dangerous, and it's non-standard in any way if you look at single sign-on. You can only have support for web applications, and the solutions that we looked at only had support for one domain, but it scales very well. So in the end, we chose a combination of these three authentication schemes in order to make what is for the user experienced as single sign-on. But the cookie solution is the core of our single sign-on. We have a solution where the login is done only once for all services. The username and the password is entered at a single and well-protected login server, and we never send passwords to other web servers. The solution that we chose is based on pop cookies from University of Washington, but there are a lot of alternatives. Klingenstein mentioned one of them, A-Select, and there are CAS and WebAuth, and a lot of different things, different technologies which could be used. We chose pop cookie because it had some features which we liked very much. First of all, the solution here is based on one central login server, which can be protected very well. The cookies and the passwords are protected by secure socket layer and host domains, and there are no browser extensions required. This means that we do not have to control the user environment. They have a browser, and that's all they need. It's platform neutral, both on the client and the server side, which is, from our point of view, considered a very big advantage. And it has this plug-in architecture for backend verifiers. This was very important for us because we wanted to do authentication and authorization. Because, as I mentioned, in the Hugo database, we have service codes, so we are able to do some simple form of authorization while we're doing the authentication. Although this may not be the theoretical correct way to do it, it does in fact lift off a lot of authorization problems for the application. And PopCookie has plug-in modules for Apache and IIS web servers, which are the most commonly used. So this was the product that we chose, and we had some very good experience with it. Just some schematic showing how this works when the user logs into the application, application 1, here. If the user does not have a ticket for that application, he or she is redirected to the login server at the bottom, where you are presented with a login form, and then it is checked whether it is the correct user ID password combination, and it is checked whether you are authorized to actually use that application. That information is then sent back you're redirected to the application, and you can start using it. So this is, for the user, seems a normal login to that application. Then when you go to the next application, you are then redirected again, but now you have a login. The authorization is checked, and then you can use the application 2, 3, 4, etc. And for the user, this is experienced as a single sign-on. Some say that this is not the right single sign-on, I don't know, but for the user it is experienced as a single sign-on. So it has a lot of advantages, but it also has a few problems. The main problem is in fact that some external applications cannot be part of this, security scheme. There can be different causes. One of them is that for some applications it is not desirable to use SSL. We have a picture database where the users with very thin, with very weak software on the client side, it will deteriorate the performance if you have to use SSL. We have, of course, some which are on an external DNS domain. PubCookie was developed as an intra-institutional application, and we want to use it as a nationwide, extra-institutional application. And for some applications, there are no PubCookie module available. So there can be a number of different reasons why you cannot use the PubCookie application, the PubCookie technology directly. So what we have done is we have developed a single sign-on proxy solution where we communicate the authorization information in a fingerprint and base the security model on a shared secret. This works in the following way. We have an external application. The user tries to get into contact with that external application. If maybe it has already got a ticket for that, then it just continues. But if not, the external application redirects the user back to the proxy. The proxy then directs the user, if it is not already logged into the single sign-on, down to the login server. And the proxy is protected by the PubCookie. So it can redirect, and what we have just explained in the previous slide can now go on again. The user is logged in, back to the proxy, and here a URL is designed that directs the user back with what is in effect a signature based on MD5. So the external application can log in the user and make its own authorization if necessary. This again will work for the user, will seem for the user to be single sign-on. And with this solution, you can have all kinds of external applications built into this single sign-on solution. The next steps that we want to take are, of course, to have more of these external applications within the single sign-on solution. And we are progressing very much on that. This, in fact, is the business model for the whole single sign-on solution, because our own applications, of course, they can make their contributions to the technology development that is necessary. But when the external suppliers, the publishers, etc., that wants to deliver their goods to the educational sector in Denmark, they come in and be part of this. They have to pay for taking part of this single sign-on infrastructure. And they are very willing to pay. Of course, we can always discuss the price, but they are willing to pay to be part of that. So that is, in fact, the business model for it. We want to do better synchronization with the local user administration. The sign-on that the user sees at the start of the day is most typically, like it or not, a Windows login. And it is possible to make integration through this proxy solution, so that the information can actually be part of the single sign-on solution. We have some ideas that if certificates become more widespread, we want them to replace the user ID password dialog. That is something that should be possible. And then we want to have a more sophisticated logout model. At the moment, PubCookie does have a logout, but it's not sophisticated enough. If the browser crashes, if other things happen, then it is possible to have a session cookies and login cookies still open, which is, of course, not so very nice to have. So we are doing some work there to make it a more robust and stable global logout. As I said, PubCookie is the base of this. We have done some very small extensions to the PubCookie technology. These has to do with the authorization mainly. The engineers told me that it was only 3 lines of code, but when I should see the documentation for it, it was a bit more, but it's not much. And for the logout, we're also doing some modification. And for the proxy solution, of course, we have had to modify the PubCookie solution. But PubCookie is the core of the solution. concluding, I would say that we have deployed a web-based single login and single sign-on infrastructure. We are in the process of migrating the web-based services to it. And we think that of course, the pub cookie technology was the major part, but then the central user database with the delegated administration was something that made it possible for us to do. We see very much interest from third parties, especially the commercial providers, to hook into this single sign-on infrastructure in order to offer their services to the community. And as I said, we see this as the life guarantee of this single sign-on infrastructure, because they will actually be paying for these services, and so we can hopefully develop it further in the future. Yeah, thank you.
Any questions, please? Okay, none. Very good.
There was
Is that
one
right?
there.
Oh, there was. I missed it. Okay, apologise. Yeah.
Just to confirm I've understood the proxy system correctly, when you add a new application to the proxy, I get the impression you need to write another back-end plug-in for the proxy so it understands how the application wants to be logged into.
Oh yes,
Is that right?
yes,
Yeah.
yes,
Okay.
that's right. We have started off by choosing some of the most common application and web servers type, you know, saying to the external applications, we support these type of applications. But of course we have to, in principle, develop each time. That's right.
Thanks.
Just one comment. You'll be pleased to know that in our most recent PubCookie release, there is a feature to work across DNS domains. It's not as well integrated as it might be, but it does work and would presumably get you out of the proxy thing for perhaps some of the remote applications. So that's a new feature.
Yes, we are aware of that, and then one of the last thing I talked with them about was whether we would, how we would be able to use it, and I think they will be able to use it. They have to look more into how well it's integrated. So, but I think, and I must say, if anyone is, we chose PubCookie because it's stable. Maybe it doesn't have that many functions, but they are very well chosen, and it seems that the development is going in the right directions. The global logout, the more than one domain, and there are a number of things that are going the right way. So we think it's a good technology. Okay. Yeah.
Okay, our next speakers from France, and the people who've developed the Sympa mailing list system. This is a very popular mailing list system used by the internet too. I noticed the other day for the login to their mailing lists. And they're going to talk about the security that they've put into Sympa in terms of authentication and authorization. So I think there's probably going to be two speakers during this session. Is that right, Serge? Are there going to be two speakers?
Yes.
Yes. So Serge,
Second speaker is
Oliver. Yeah. So Serge Oman is going to start, and then halfway through, Olivia Saloon will take over. Thank you.
Okay. So what I will present you is the same problematics, but view from the application. So the problem is authentication and authorization, and there are some speakers who describe wonderful single sign-on and beautiful national initiative for a unique authorization architecture.
and developers have to provide application compatible with this. So let's say yet another mailing list manager. Why? Well, it is homemade, and we are a French network technical team, and we need an application to operate a service at the national level. So with a lot of customization for different usage. And we need also scalability, so many lists and many subscribers. We also have introduced some features that we didn't find in other mailing list software, such as a list document repository, because lists are usually a tool for working groups. And the Sympa provide 3 interfaces: classical mail robot interface, web interface, and also a SOAP server. The web interface is a full portal of all the service, including administration, list creation, list deletion, etc. And a single server can provide several mailing list servers with virtual hosting. And another example of advantage features is that mailing list can be extracted from LDAP directories, and not only using add and delete command. Now, focusing on authentication. The authentication method available depend on the interface where the service is accessed. The sender of a message, of course, with a confirmation challenge, is a kind of authentication. Passwords are available on the web. The password can be internal or use LDAP authentication backend. There is also a single sign-on. Already two different systems. CAS, the Yale University single sign-on system, which is used on web and SOAP interface, and Shibboleth, which is introduced in Sympa. And of course, we also use user certificate on both email interface and web interface. Why? Why do we provide so many authentication methods? What we want is not a tool for an intranet where everybody can use the same authentication method. We want a mailing list server to be used by many users from different origin. And as you know, there is not already a world Shibboleth Federation to provide authentication service to anybody. So we need to support multiple authentication service at the same time. And the system choose the appropriate authentication server depending on various information, mainly the user email when this is possible. About user certificate authentication, on the web interface it is very simple. It uses Apache and ModSSL environment variable inheritance. So there is not a lot of things to say about it. On the mail interface, Sympa recognize and checks the SMIME signature using OpenSSL at the current point of development of this feature in OpenSSL. So there is some limitation on CRL, for example. This is out of the topic of authentication, but Sympa also supports SMIME encryption in order to distribute encrypted message to all subscribers. You can have a paper about this on Sympa site. And now, CAS, the Central Authentication Service from here. So I suppose many of you know about CAS. It is very similar to other single sign-on systems that have been mentioned in this conference. It uses widely cookies, redirection, and a ticket that must be validated against a CAS server. We choose CAS firstly because this was a demand from French universities that want a system which supports proxy credential to integrate services in uPortal. I will now show you why it is not so easy to introduce CAS in Sympa. CAS claims to be very easy to integrate in application, but I'm not sure it is always the case. The normal configuration is one server, one client, and only one CAS server. In this case, Sympa acts as any other application interfacing with CAS. It's to say, if useful, redirect the user to the authentication server, and he will get back a ticket with another redirection, and this ticket is transformed by to a user ID. Now, Sympa is a mailing list server. It has nothing to do with user ID. It needs a user email. So Sympa will fetch a user email in a LDAP directory, and the authentication is done. The client receives the welcome page. Now, what we have done is a way to install Sympa and configure it to interface multiple CAS servers. So when a client connects, the Sympa redirect it to a CAS server. We don't know which one, but using a non-blocking redirection is to say a redirection where the result is only to know if the user is already connected or not. But if the user is not connected, he will not have to connect to this CAS server. We just know that it is not connected. So in this case, we redirect it to a second CAS server, and hopefully it was already connected. So the rest of the session is similar, and we show the welcome page to the client. Now, what's happened if there was not only no session initialized with any CAS server? Sympa, in this case, will present a kind of where are you from formula in order to ask to the client which CAS server is depending on, and then do a redirection to this CAS server. So the CAS server will show a logging formula, and the process continue in a similar way. So these schemes show several limitations about CAS. One question is what happens if a CAS server is out of order? And the result is not very good because any redirection to this CAS server is a dead end. So user will have an error page and there is nothing to do to provide another solution. So we know that we must not configure Sympa with a lot of CAS server because they will always have some problems. Anyway, what we can do is to detect that a CAS server is out of order and then do not play automatic redirection to this server, or to disable this feature by configuration in Sympa. So that's a consideration about global logout, which has been made by the previous speaker. So I don't. Sure. Here is the main page of a Sympa server, and you can see that on the same server you can use basic login password authentication. Sometimes there is a LDAP backend you don't know, so user don't know. You can use your certificate to log, and you can choose a CAS server to be redirected to it. And so you will have access to your subscription button if you are authenticated. So here is a scheme of the different authentication method integrated into Sympa. All can be used together, and there is always a second step, which is how to get a user attribute, because the minimum attribute needed by Sympa is the user email. Okay, and now Sympa Olivier will speak you about authorization and shibboleth.
Hello. So we now deal about the two pieces of this scheme, which is the authorization engine at the top, and the example of shibboleth integration at the bottom right. Okay. So how about access control in Sympa? It is strictly separated from the authentication process and separated from the code. It can also be applied to unauthenticated users, because users can access public pages such as the web archives without authenticating. The access control can be configured for each list and each feature, including subscription, the sending process, review, visibility, and also the creation of mailing lists itself. The way we define access control is extensible for the list masters, thanks to the authorization scenarios, which is the name of our authorization language. Note also that the authorization is applied exactly the same way on the three interfaces, which are, as Serge told you earlier, the web, mail, and SOAP interfaces. So here is a short description of the authorization scenarios, which is Sympa's native ACL. a scenario is evaluated to provide the access to one of the features I listed briefly earlier. And it makes especially the web interface very well adapted to the user, because we will never advertise features that the user cannot access. You will not see the archive button or the review button if he's not allowed to. A scenario is made of ordered rules. I will show you an example just afterward. And each rule is made of three components, which are the condition, an authentication method, and an action, which is a kind of decision that Sympa will take. And note that the condition can make use of LDAP user attributes. That's what you can see in the previous schema, the organization of Sympa. So here is a simple example of an authorization scenario, which is aimed at defining who is allowed to distribute a message for a list. The expected behavior would be to have a private list with moderation of messages for multi-part messages, which is quite common because sometimes people send big attachments, but anyway. And the third element in this example would be a requirement for moderators to be SMIME authenticated. Yep, and here we are. So on the left-hand side, in blue, you have the condition part of each rule. In the middle, in yellow, green, you have the authentication method required, which can be an MD5, which means in Sympa challenge password that is sent to the user at his email address. And SMIME, I won't detail it. And PGP will be available soon. And then on the right-hand side, you've got the action that is done. I won't detail all the rules, and you can have a look at the Sympa documentation later, maybe. Just note that the scenario is evaluated line by line and will stop once a rule is matched. And okay. Now another team, which is Shibboleth. Maybe it's not an important slide because you must be aware of that. Let's rather talk about the integration with Sympa. Why into plugging Shibboleth with Sympa? The usage, in our point of view, is to build interinstitutional mailing list with a strict definition of the targeted population without managing authentication for each user. I imagine that this is a definition of virtual organization. The prerequisites for each institution is of course to have a Shibboleth target package installed and its local single sign-on. And of course to have a common definition of the attribute semantic via a schema. Otherwise you won't speak the same language. Okay, so here is how it works. So we have shown in this schema which is very schematic. Sympa has something with a public area and a restricted area, and a login in the middle. Okay, so when the user accesses the public area, there is no problem, of course. but when it accesses the restricted area, it is redirected to the login feature, which has in front of it, in certain situations, Shibboleth Resource Manager that will redirect the user to the Shibboleth target, including the shire, which will redirect him to the where are you from, and then to the origin, and we will be able to get the identity of the user as well as his attributes that will be sent back via the resource manager to Sympa. Note that the user attributes will be kept by Sympa in a cache in database to have later use. But this cache has only the time life of the session for the user, of course. So now let's talk about how Sympa will use these attributes. So these attributes are inherited via the environment variables because the resource manager is basically an Apache module. So they are stored in Sympa session database and used in the authorization scenario engine. And here is an example of this use. So this is a small piece of a scenario that could be more complicated, where that will check if the user that is authenticated belongs to either geology student or archaeology student. And if so, we will grant him access to the requested future, which can be any future. And then later you can have other rules that will reject other populations. Here we are. So I will conclude by saying that Sympa users include mainly French academic institutions, but more and more foreign universities. And these people are driving the developments of Sympa. We have been introducing into Sympa LDAP, SMIME, and now single sign-on futures because it was of use for academic institutions. And we will go on this way. And what about AA development plans? There is a need to integrate SAML authentication in the SOAP interface to allow a delegation of authentication. We could, for instance, let the user authenticate in a tiers application, and then this application could contact the Sympa SOAP server and get all the subscription for this user. But actually, it has to send the credentials for the user, unless he is using CAS, which implements this feature. But we hope that SAML would allow that. Maybe not. We'd like also to build a stronger user attributes layer in Sympa architecture. You saw it maybe previously in the architecture. There is an user attributes layer that needs to be stronger and more abstract maybe. We also wish to introduce validating and validate Sympa with other single sign-on system. Actually, the development we've made for Shibboleth is not called in the configuration Shibboleth. It's called generic SSO because it just basically gets attributes from the web server via any module. So any single sign-on system should be able to use these developments, but we would like to test this with other single sign-on system, of course. Okay, and a last thing that is not mentioned here is dealing with X509. Currently, Sympa is collecting the X509 user certificates when users are sending messages like subscription command. And we would like to link Sympa with LDAP directories to do the research for certificates, which would be more scalable. Okay, thank you.
Okay, thank you very much. So if we have any questions for the two speakers, please. I think everybody's wanting to go for their evening meal. So if we've got no questions, we'll thank you once again.